March 5, 2026, dawned with a jolt in northwestern Louisiana, a magnitude 4.9 earthquake, shaking the region awake before the sun had fully risen. The early morning calm was shattered in an instant, as a deep rumble rolled beneath the streets and fields, sending a wave of confusion and fear through communities unaccustomed to such tremors. This was the strongest earthquake ever recorded in the state's history, a record-breaking event that would soon dominate local conversations and news reports. At 5:30 a.m., the ground shook violently, startling residents more accustomed to jazz than seismic surprises. People rushed from their beds, some grabbing loved ones, others simply standing in disbelief as their homes rattled and windows trembled. The quake's epicenter was about 36 miles south-southeast of Shreveport, at a shallow depth of just over 3 miles. This shallow focus amplified the shaking, making it feel even more intense for those living nearby. The rural landscape, usually so peaceful at dawn, was suddenly alive with uncertainty. But this wasn't an isolated event. In the days that followed, the earth remained restless. On March 9th, 4 more earthquakes struck near the small town of Edgefield, forming what scientists call a rare seismic swarm, an unusual cluster of quakes in a short period. These aftershocks ranged from magnitude 3.1 to 4.0, enough to keep nerves frayed and residents on edge. Each new tremor brought fresh anxiety, as people wondered if the worst was yet to come. For Louisiana, a state with little history of earthquakes, this was a seismic wake-up call. The ground beneath their feet, once thought to be stable and predictable, had become a source of uncertainty. The cluster of quakes transformed what could have been a single, startling surprise into a full-blown geological phenomenon. Maps lit up with new data points, and experts scrambled to understand what was happening beneath the surface. Suddenly, one of the nation's quietest tectonic regions was making headlines. News outlets across the country picked up the story, and Louisiana found itself at the center of a scientific mystery. The Earth's unexpected performance left scientists and residents alike searching for answers. Was this a one-time anomaly, or a sign of something more? Louisiana's reputation for geological calm had been shaken, literally. As the dust settled, the state faced a new reality. The ground beneath their feet was not as quiet as they once believed. Louisiana sits far from active plate boundaries, making it one of the least earthquake-prone states in the U.S. Historically, quakes above magnitude 4.0 have been almost unheard of here. Before 2026, only minor tremors, barely felt, occasionally caught scientists' attention. The state's infrastructure and public mindset were shaped by this long-standing seismic piece. But in late 2025, a subtle uptick in small quakes hinted at change. The leap from minor tremors to a 4.9 event has rewritten Louisiana's geological script. Suddenly, the quiet bayou state is anything but. Louisiana's record quake fits into a broader, if infrequent, pattern of Gulf Coast seismicity. The region isn't as quiet as it seems. Texas experienced a 4.8 quake near Timpson in 2012, just 57 miles from Louisiana's epicenter. Offshore, the Gulf of Mexico has seen even stronger quakes, like a 5.3 in 2006. While these offshore events rarely impact land, the recent Louisiana quake is unprecedented for the state itself. It's a reminder that hidden faults and ancient stresses can still surprise us. The Earth's crust here is more dynamic than most realize. Even in stable regions, powerful forces are at work beneath our feet. The Gulf Coast's seismic history is rare, but not non-existent. Louisiana's quake is now part of that story. Earthquakes are sudden, powerful movements of the ground that can shake entire cities and landscapes. But what actually causes them? Deep beneath our feet, the Earth's crust is not a single solid shell. It's made up of massive slabs called tectonic plates. These plates are constantly moving, though usually at a pace too slow for us to notice. Along the boundaries where these plates meet, or even within the plates themselves, cracks called faults form. Over time, stress builds up along these faults as the plates push, pull, or slide past each other. Eventually, the stress becomes too great, and the rocks suddenly slip, releasing a burst of energy. Most earthquakes happen at the edges of these plates, where the forces are strongest. However, Faults can exist anywhere, even in the middle of continents, far from the plate boundaries. This means that earthquakes can strike in places where people might not expect them, like Louisiana. Friction along the fault holds the rocks in place, resisting movement. But as pressure builds, it eventually overcomes the friction, causing the rocks to break or slip. This sudden movement releases energy in the form of seismic waves, which travel through the ground and cause the shaking we feel during an earthquake. The exact spot underground where the rocks break is called the focus, or hypocenter. Directly above it, on the Earth's surface, is the epicenter, the point where the shaking is usually felt the strongest. Scientists measure the size of an earthquake using magnitude, which tells us how much energy was released. Each increase of one whole number on the magnitude scale means the quake is about 32 times more powerful than the last. So, even a small jump in magnitude can mean a huge difference in impact. That's why Louisiana's recent leap from minor tremors to a magnitude 4.9 earthquake was so dramatic and surprising for residents. It was a sudden reminder of the power hidden beneath the ground. When an earthquake strikes, seismic waves ripple outward from the epicenter, shaking the ground and startling communities. The effects can be felt for miles, sometimes even in places where earthquakes are rare. Even in regions far from active plate boundaries, ancient faults can awaken after lying dormant for thousands or even millions of years. These hidden cracks in the earth can suddenly become active again, catching people off guard. The recent earthquakes in Louisiana and other unexpected places show that no region is completely immune to the restless energy of our planet. Earthquakes can happen almost anywhere, reminding us of the dynamic nature of the ground beneath us. By understanding how earthquakes work and where they might strike, we can better prepare ourselves and our communities for the unexpected, helping to keep everyone safer when the ground begins to move. The shock wasn't just the shaking, it was the mystery behind it. For most people in Louisiana, earthquakes are something you hear about happening far away, not something you feel under your own feet. The sudden tremors left residents and experts alike searching for answers, as the state is not known for seismic activity. Unlike California, Louisiana has no major active faults mapped beneath it. The region is considered geologically stable, with only minor, infrequent quakes recorded in the past. This makes the recent events all the more puzzling, as there's no obvious culprit beneath the surface. Geologists suspect ancient hidden faults may have been reactivated by subtle long-range stresses. These faults, buried deep beneath layers of sediment, could have lain dormant for millions of years, only to be awakened by forces we're just beginning to understand. Why now? Why here? Those are the questions scientists are racing to answer. The timing and location of these quakes have sparked intense debate and curiosity within the scientific community, as they challenge long-held assumptions about the region's stability. Some wonder if oil and gas activity could play a role, as seen in Texas and Oklahoma, but it's too soon to say. While human activity has triggered earthquakes elsewhere, the connection here remains unclear, and researchers are cautious about drawing conclusions without more evidence. Investigators are poring over seismic data and industrial records for clues. They're examining every possible factor, from groundwater changes to industrial operations, hoping to piece together the story behind these unexpected tremors. The event challenges our understanding of the region's geology. It's forcing scientists to revisit old maps, re-examine core samples, and rethink what they know about Louisiana's underground landscape. It's a scientific wake-up call and a rare research opportunity. For geologists and students alike, these quakes offer a chance to learn more about the hidden forces shaping our world and to improve our ability to predict and prepare for future events. These quakes remind us that the Earth still holds secrets, even in the most unlikely places. Even in regions thought to be quiet and safe, the planet can surprise us, revealing new mysteries just beneath our feet. The data gathered will shape our knowledge for years to come. Each new discovery brings us closer to understanding the complex and dynamic nature of our planet, and helps us prepare for whatever surprises may lie ahead. Despite the record quake, damage was minor, mostly fallen items, cracked plaster, and rattled nerves. Residents across Louisiana, Texas, and Arkansas woke to shaking houses and vibrating windows. Emergency agencies fielded calls, reassured the public, and checked for hazards like gas leaks. The real impact was psychological, a community forced to confront a new threat. Aftershocks kept anxiety high, reminding everyone that the ground could move again. The event exposed the vulnerability of a region unprepared for earthquakes. It's a warning. Even moderate quakes can disrupt places that don't expect them. The biggest shift was in mindset. Earthquakes can happen here too. Geologists are now hunting for the fault responsible for Louisiana's seismic surprise. Ancient, mostly dormant faults crisscross the region, but few were thought capable of such activity. Using seismic tomography, like a CAT scan for the Earth, scientists are mapping the hidden structures below. The likely culprit may be a previously unmapped or misunderstood fault, buried deep beneath thick sediments. Each quake provides new data, helping to illuminate Louisiana's hidden geology. Researchers are also studying how stresses across the North American plate might have triggered this event. The investigation could reveal why these ancient faults finally gave way after millions of years. Louisiana's quakes are a wake-up call. Earthquakes can happen almost anywhere. Basic earthquake safety, drop, cover, and hold on, matters, even outside California. Secure heavy furniture, move hazards away from beds, and keep an emergency kit ready. Simple steps can make a big difference if the ground shakes again. The key is awareness, not fear. The "it can't happen here" mindset is no longer safe. Even if the risk is low, preparation is a smart investment. Talk with your family or coworkers about what to do in an earthquake. Science and preparation are our best defenses against nature's surprises. The Louisiana quakes prove that readiness is for everyone. The 2026 Louisiana earthquake swarm will be remembered for the awareness it sparked, not the damage it caused. Scientists now have a rare natural laboratory to study intraplate earthquakes. Officials are rethinking building codes and emergency plans for future resilience. For the public, the biggest change is a new respect for the ground beneath their feet. This event encourages scientific curiosity and a culture of preparedness. Louisiana's geological innocence is gone, replaced by informed vigilance. The Earth's quietest corners can still surprise us. The conversation about seismic safety in Louisiana has only just begun.